So with the idea of a path and a circuit in mind, now we'll think about what it looks like to traverse a graph. And we're going to come back to this Königsberg bridge problem, which we looked at in the last lecture. And hopefully you've been thinking about this and thinking about how you would find a path or a circuit that would cover all the bridges exactly once, or cross each of them exactly once. Now in the standard formulation of the problem, it's a circuit. So you're looking for coming back to the same location where you started. But you can also do it with a path, looking for a path through this graph. So we drew this picture and then we drew a graph that went with it. The graph is the, again, sort of idealized version of this map, where we have a node representing each landmass and edges representing all the bridges that connect them. So with our new terminology, our new language of paths and circuits, we can rephrase this question in a more official kind of graph theory way. Rather than just saying, can you cross each bridge exactly once, we can just look at the graph and ask the question, is there a simple circuit? Remember, the idea of a simple circuit is one that does not retrace any edge, doesn't pass or cover any edge more than once. So is there a simple circuit that contains every edge? Now clearly you could draw simple circuits that would not contain every edge, but for this question we want one that contains every edge. And since Euler started working on this problem, we defined this term, the simple circuit that contains every edge, we have a name for it called an Euler circuit. So an Euler circuit is exactly that. It's a circuit through the graph that contains every edge exactly once. So it contains every edge, and the fact that it's a simple circuit means it doesn't contain any more than once. So it contains every edge exactly once. You can also have an Euler path, which is the same idea except replace the word circuit with path. So an Euler path would be a simple path that contains every edge. So that's kind of the formulation of the problem, is taking this map, turning it into a graph, and then focusing the question on asking, is there an Euler circuit through this graph? Once we formulate the problem that way, then we can focus on figuring out how to tell whether or not there's an Euler circuit. Even if we don't necessarily know what the Euler circuit is right away, there's a simple rule that will tell us how, or will tell us whether or not that circuit exists. And we'll look at that a little bit later.